Yes, sir.
Okay, very good. জানি আমাকে কোন সময় যদি visibility না হয়. Okay, there are three characteristics on which a transducer can be selected: input characteristics, transfer characteristics, and output characteristics. First is input characteristics, which is classified into three types: type of input, operating range, and loading effect. Type of input means what is the input energy. Operating range means usable minimum and maximum value of input that can be applied. And loading effect means how much changes, or what is the value change of input quantity, input physical quantity, when transducer is connected. Then comes transfer characteristics. There are three: transfer function, errors, and response of transducer to environmental influence. Transfer function is relationship connecting input to output. Basically, it is a function h which is equal to output divided by input. Then comes error. Error is measured value minus transfer function value. Because transfer function gives a theoretical value. And it's assumed that transfer function value is ideal or correct before we start the experiment. But measured value is actual experimental value. And experimental values are never ideal. Now, last one is response of the transducer to environmental influence. That means when you are using the transducer, then what changes do you see? What changes do you see? Okay. Now comes this one, transfer characteristics. Let's discuss the transfer characteristics. First is transfer function, then error, response of transducer. Transfer function, basically, it's the input-output relationship. If X is the input, and this is your transducer, and Y is the output, then Y must be some function of X. And this we can mathematically express as Y is equal to f of X. F is that function, that mathematical relationship. Sensitivity. It can be defined as rate of change, or it says how fast the output changes when the input has changed. And any changes or rate of changes are given by derivative. Since this is a change of output, d of output with respect to t of input. That is the definition of sensitivity. Sensitivity has a commercial name. It's called the scale factor. This is your bookish name or technical name. And this one is market name or commercial name. So sensitivity and scale factor are same. Second is linear transducer. What is linear? If the output varies, output voltage varies proportional to the input quantity. In that case, your sensitivity will be a constant value. Remember these things. Non-linear, your output does not vary, that does not directly change or proportionally change with the input. Rather, its sensitivity itself is a function of the input quantity. Next come errors. Errors means how much will the measured value deviate from theoretical value. So generally, the measured value is the one which you can see, and theoretical value is the one which you can calculate from transfer function. So if you can see something, we believe in that. And the theoretical value, what will happen is, the theoretical value we can derive it under ideal circumstances. So measured value will change or will deviate from the theoretical value or the transfer function value, and that difference will be termed as error. So error can be again classified into three types: scale, dynamic, and error due to noise or drift. The scale error again is classified into three types. That is zero error, sensitivity error, non-conformity, and hysteresis. So first one is scale error. Scale error means every measuring instrument has a scale and requires calibration. So if that scale is wrong, then we say that a scale error had happened. Since all transducers have a purpose, they all measure something, or they output some electrical voltage or current. That means they may output wrong voltage or wrong current. Those wrong voltage and current will give rise to wrong readings on your instrument scale. Those type of errors are called scale errors. So zero error, if the measured zero and the actual zero doesn't coincide. Measured zero means if you remove the input, you get some output. So we know that if, for instance, a voltmeter is left open, it should display 0 volt, but you are seeing that it's displaying 0.01 volt. That means the zeros are not accurate. Like when it should have shown 0 voltage, it's showing 0.01. That is a zero error. The zeros are not coinciding. That error is a linear error. That means it will stay same forever. Even if the reading changes, say for the same voltmeter, you attach a 5 voltage battery. If you have a zero error of 0.01 plus 0.01, 5 voltage will appear as 5.01 volt. Second is sensitivity error. Sensitivity error means the instrument is either more sensitive, I mean they are responding more, or they are responding less than what is desired. That means the transducer may sense or respond more, and sometimes it may respond less. Say you have a temperature sensor where you input temperature and you get output voltage. if you assume that for 1 degree rise in temperature, your voltage changes by 1 volt. That means for 100 degrees centigrade, it should show 100 volt. For 101 degrees centigrade, it should show 101 volt. But it seems that you are getting 100 voltage here, 110 voltage here, or somehow 120 voltage for 102 degrees centigrade, 103 you are getting 135 voltage. So instead of outputting a proper value, what is happening is it is showing a multiplicity of value that is exponentially rising. Those type of errors are called sensitivity errors. In general, they are related to the theoretical output by a multiplicity factor k. So you have theoretical error or transfer function value into some constant will give the measured value. So this is a multiplicity error. Zero error is an additive error. That means the error is added to the transfer function value. But sensitivity error is a multiplicity error. You will multiply some constant value or some value to your transfer function value. Next is non-conformity. Non-conformity is like a non-linear error. It's like there is no relationship between what you are getting and what the theoretical value is. Your theoretical value may be a straight line, along a straight line, but what you are getting is random fluctuations in the output. So for instance, sometimes you're trying to measure 5 voltage, you're getting 5.1 voltage, sometimes 4.9 voltage. It is never giving you 5 voltage. This type of error are called non-conformity error, where you don't have a relationship with your input and output. Okay. This one is one slide. আচ্ছা তোমরা কি আছো সবাই?
হ্যাঁ স্যার আপনি স্যার।
হ্যাঁ স্যার।
বড় চুপ হয়ে গেছে, বড্ড বেশি চুপ। আচ্ছা, for next, hysteresis. Hysteresis error means suppose you are like a rubber band, the thing gets deformed, the transducer is getting deformed. How is it happening? First, say for instance you are applying some load on a pressure strain gauge. So as you increase the mass, as you increase the load mass, your output should increase, output voltage should increase. It is happening properly. But when you are decreasing the mass, you are seeing that you are getting, as you decrease, you are getting more voltage than when you are increasing. And ultimately, when you release the strain gauge and it returns to its initial position, it's still showing some voltage value. That is not zero. That means it is no more relaxed. It has some hysteresis. That is, it is carrying some strain in it. So those type of error where the transducer seems like it is getting deformed is called hysteresis error. Your objective should be to minimize hysteresis error. Okay, any question? চলো কার তো কোনো কোশ্চেন?
জিরো এরর আর হিস্টেরিসিস এরর ওটা আরেকবার একটু এক্সপ্লেইন করবেন?
আচ্ছা, জিরো এরর হচ্ছে অ্যাডিটিভ এরর। জিরো এরর মানে সাপোজ ফর ইনস্টেন্স ইউর zeros are not coinciding, এটা মনে রাখো, zeros are not coinciding. You have a voltmeter you apply nothing. আচ্ছা ওপেন যদি ভোল্ট মিটারকে রাখো তাহলে আউটপুট কি দেওয়া উচিত? কোনো কিছু কানেক্ট করনি, কোনো ব্যাটারি নেই, the output should be how much? কেউ বলো আনসার শুনি।
কিছু কানেক্ট না করা থাকলে জিরোই আসবে।
জিরো আসছে, কিন্তু দেখা যাচ্ছে যে তোমার মিটারে আউটপুট দেখাচ্ছে 0.05 ভোল্টেজ। এই যে জিরোটা কোইনসাইড করছে না, দ্যাট মিন্স ইনস্টেড অফ গিভিং 0 it is showing 0.05. This type of error are called zero error. তো এতে যদি 5 ভোল্টেজ লাগাও, কানেক্টিভিটি দাও, so it should have shown 5 voltage, but এখন zero error এর জন্য it will show 5.05 voltage. মানে always this type of error is additive. It is added to the value, actual value or theoretical value. And hysteresis মানে হচ্ছে the device is getting deformed. যখন ডিফরমেশন হয় তখন চেহারাটা এক থাকে না। So what is happening is as you are increasing the weight, the device is following its original path, like whatever it's predicted. But দেখা যাচ্ছে when you, after you have increased the weight to a certain point in a strain gauge, for instance in a strain gauge কি করে কেউ বলতে পারবে? What is the purpose of strain gauge, electrical strain gauge? Converts strain or load into electrical voltage. তুমি যত ওয়েট চাপাবে তত বেশি ইলেকট্রিক্যাল ভোল্টেজ পাবে। So if your strain goes on increasing, it seems that your electrical voltage is varying as predicted. But যখন ওয়েটটা কমানো হচ্ছে এটা দেখা যাচ্ছে ইলেকট্রিক্যাল ভোল্টেজটাও কমা উচিত ছিল, and it should have followed this red path, but দেখা যাচ্ছে it is following this blue path. That means আগে যা ভ্যালু হচ্ছিল ওয়েট বাড়ার সময়, you are not getting that when the weight is getting reduced. And finally যখন পুরো ওয়েটটা উঠিয়ে দেওয়া হলো, that the strain gauge is now should have been relaxed and outputting 0 volt. দেখা যাচ্ছে অন্য কিছু একটা আউটপুট দিচ্ছে, just say 0.1 volt আউটপুট দিচ্ছে। তার মানে strain gauge is still reading that there is a weight, but তুমি তো actually weight চাপাওনি। So the result is that the gauge is now deformed. It can be assumed that it is now deformed. This deformation is also called hysteresis, or the gauge. Why is it called hysteresis? Because it seems that the gauge is remembering its past values. This type of hysteresis results in an error called hysteresis error. And your objective when you are selecting a transducer or designing one, you should minimize this hysteresis error. Now let's go to the next one, dynamic error. When suppose you apply something, dynamic error is a error which varies with time. Generally, this dynamic error is one only type of error which decreases with time. What does this mean? তুমি একটা টাইম প্লট করলে, say you want to achieve this final value, the black line. In case if dynamic error was not there, or in ideal case, তাহলে এটা তুমি ইমিডিয়েটলি যখন ডিজায়ার্ড একটা ভ্যালু চাইছো, ব্ল্যাক লাইনটা হচ্ছে ডিজায়ার্ড আউটপুট যেটা তুমি চাইছো। So if you want some desired output, in ideal case, the device or the transducer should have switched or should have outputted this value only when it has started. But because of dynamic error or because of reality, you immediately cannot achieve this value. You will achieve this value slowly, gradually over time. So what is happening? If you measure at this point, your device is now outputting this value, but you desire this value. This difference in value is known as dynamic error. Okay. Clear? Dynamic error. Remember, this one is a function of time. Dynamic error will reduce, and after very long time of operating the device, the device should have achieved the final value, but still there will be an error. Will be a very small error. This error is known as steady state error. Okay? তোমরা কি শুনছো?
হ্যাঁ স্যার
Hello?
শুনছি।
হ্যাঁ, মনে তো হচ্ছে না কারুকে। সব তো সোমবারে মনে হচ্ছে রেস্টে রয়েছে, সানডে মুডে।
না না, তাও কানে আপনার কথাটা বাজছে, আপনি বলে যান।
আমি বলে গেলে আমার লাভ কি? আমারই মুখস্থ হয়ে যাবে, তোমরা ভুলে যাবে সব।
না না, ভুলবো না ভুলবো না।
Okay, now next one. Noise. What is noise? Noise are fast random variation, and there is something other than noise, that is drift. Drift is slow variation. Drift happens because of environmental factors. Drift, thermal effect, then dust, aging, etc. But noise can happen. Generally, noise increases when there is some problem with connections, and sometimes due to dust. But there is no real explanation for noise. There are types of noise which you can categorize, but even in the absence of everything, there is something called a thermal noise. So noise is something which cannot be avoided, and drift is something that can be avoided if you are properly cleaning and maintaining everything. But the difference between noise and drift is that drift is slow variation while noise is very fast, and this can affect your operation and you cannot get rid of it, although drift can be. So this is a small point you may remember. Second is frequency response. Frequency response is transducer doesn't respond to all signal. This one, when you're studying frequency response, it means how fast your transducer responds to a changing signal. So when your input is changing, your transducer may respond or may not respond. It will depend on how fast or the rate at which input changes. Hence, if it is too fast, it will not respond. If it is too slow, it will respond. But there is certain part or a range where your transducer will be responding optimally. This range is called bandwidth. So your transducer will respond within this bandwidth. Okay, another term for rate of change is frequency. So frequency is a determining factor. It determines if your transducer will respond or not. If you change your input too fast, if it is at this range, like this frequency value, your transducer will not respond. But if your input is changing at an adequate rate, such as the frequency lies within this value, your transducer will respond properly. Generally, is the gain. How much, what is the gain or what is the output to input ratio? that the transducer will produce. Your gain will be maximum in operating frequency range of transducer. Okay, so next come the output characteristics, and we are almost out of time. Still আমি একটুখানি output characteristics বলে দেবো. Output characteristics means how will you select a transducer based on some factors at its output port. One is type of electrical output. It's not input, it's electrical output. And a transducer is outputting voltage, current, or some resistance or impedance, or some time function of amplitude. That means if you can't understand this one is fine. These three are very important. What is the transducer giving out? What is the transducer giving out? Is it giving out voltage? Is it giving out current? Is it giving out impedance? This is the most important decision. If you say, for instance, a photodiode gives out current, but a photovoltaic cell gives out voltage. For both, light is the input. So it is your decision. Like you want to have current, then you have to take photodiode. If you want voltage, you have to take photovoltaic cell. So this is the first factor. The second factor is output range. That is how much. Generally, when light falls on photodiode, the current is not that much. It is around 1 to 100 microampere. But when you're talking about photovoltaic cell, it can output up to 2 to 3 volts. So these are the output range, the value of voltage or current produced. So if you want a high output or high voltage output, you can select a photovoltaic cell. But if you want to use amplifiers and extra components, then you can use, but you don't have a requirement for high current value, then you can select a photodiode. So did you understand this one?
Yes, sir.
কি বুঝেছো? এখানে দুটো ফ্যাক্টর আছে, লোয়ার লিমিট এন্ড আপার লিমিট।
বুঝেছি ফটোডায়োড আর ফটোভোল্টাইক সেল।
কখন ইউজ করব? কখন ফটোডায়োড জাতীয় জিনিস ইউজ করব?
যখন কারেন্ট আউটপুট চাই, আর ফটোভোল্টাইক যখন ভোল্টেজ আউটপুট চাই।
সেটা তো বোঝা গেল, বাট কোনটা কোন সিনারিওতে ইউজ করব? যখন কারেন্ট রিকোয়ারমেন্ট, সে আমার কারেন্ট ভ্যালু রিকোয়ারমেন্ট খুব লো থাকবে, তখন কোনটা ইউজ করব?
ফটোডায়োড।
ওকে, ভেরি গুড। চলো, বুঝেছো?
শুনেছি। হ্যাঁ
হ্যাঁ, বোঝা যাচ্ছে যে শুনছে সবাই। আচ্ছা, নেক্সট ইজ output range. There are two ranges. One is upper range, মানে maximum value, another one is minimum value. Maximum value is upper limit. Upper limit মানে হচ্ছে কত অ্যামাউন্টের পরে the device will saturate, the transducer will saturate. Saturate মানে ওর উপরে আর বাড়বেই না, it will flatten out. তুমি যতই ইনপুট বাড়িয়ে যাও না কেন, output will increase no more. আর lower range হচ্ছে ইনপুটটা খুব কম দিলে, so there will be some output. এবার some output মানে you can reduce the input to such a level ki your signal is at least detectable, and noise ওকে কভার করে দেবে না, কারণ একদম নিচে there is noise. Noise determines the lower limit. কত মিনিমাম ইনপুট দিলে সিগন্যালটা ডিটেক্টেবল হবে নয়েজের জাস্ট উপরে। সো লোয়ার লিমিট ডিপেন্ডস অন নয়েজ, ডিভাইস নয়েজ। আপার লিমিট এটা ডিপেন্ড করছে ডিভাইসটা ক্যাপাসিটির উপরে। ফটোডায়োডের ক্ষেত্রে আপার লিমিট উইল বি সে দিস ওয়ান, লোয়ার লিমিট ইজ অ্যারাউন্ড জেনারেলি 10 ন্যানো অ্যাম্পিয়ার। তাহলে ফটোডায়োড ক্যান ওয়ার্ক ফ্রম 10 ন্যানো অ্যাম্পিয়ার টু 1 থেকে 100 ম্যাক্সিমাম 100 মাইক্রো অ্যাম্পিয়ার অবধি। This is minimum lower limit and this is upper limit. So I will stop here now and then acha 1 minute আমি তোমাদের নেব। এই অবধি কি প্রবলেম আছে বলো? 42 অবধি আমি ক্লাসটা নেব। এই অবধি কি প্রবলেম আছে বলো? আউটপুট ক্যারেক্টারিস্টিক্স এ any problem, any question? Santan, any question? Riddhima, Santan, আচ্ছা এত চুপ কেন আজকে সবাই? প্রিয়াঙ্কা তাও মাঝে মাঝে কথা বলেছে। What about the others?
না স্যার এখনো আপাতত কিছু মানে ডাউট নাই।
এখনো কোনো ডাউট নেই? Okay, then
Uh-huh.
next class we will go on to the next one, output characteristics. Okay?
ওকে স্যার।
Okay, very good. Hello, bye bye. আমি স্টপ করছি রেকর্ডিং। Stop recording.